will be affected by either the north or south poles, except when the magnet is perpendicular to a line. Let's focus on line 1. It's at its peak current when the north pole points to both 12 and 6 o'clock positions. It is at zero current when the north pole points to 3 and 9 o'clock. Only one of the three lines is ever at peak, but because there are three lines, there are 3 peak positives and 3 peak negative positions for every cycle. At 6 different positions on the clock face, one of the lines is at peak. 12 and 6 positions are line 1's alternating peaks. 2 and 8 positions are line 3's alternating peaks. And 4 and 10 are line 2's alternating peaks. Now let's explain those confusing waveforms that are frequently used to depict three-phase. If you look at the waveform example, you can see the first line in blue and it starts at 0, which means the magnet is perpendicular to that line. As the magnet moves, you can see the current go to its peak. Then as the positive pole spins past that wire, the current starts to weaken until the magnet is perpendicular again, which results in 0 current. As the negative pole starts to come closer, the current reverses and moves in the other direction towards another peak before returning to 0 current. This completes one full cycle for that line. In order for the two-dimensional chart to show the relationship between the lines, it now shows a gap that signifies the length of time it takes the magnet to spin 120 degrees. This is when the red line is at 0 current. As the magnet keeps spinning, the red line will move towards its peak positive current, then come back to 0, after which the current will change direction. The chart also shows that the third line will start at 0 current 120 degrees after the second line. So if you look at these three lines, you can see that when one line is at its peak, the other two lines are still generating current, but they're not at full strength, meaning they're not at peak. So as the electrons flow from a positive to a negative peak, the current is displayed as flowing from positive to negative values. Remember that positives and negatives don't cancel each other out. The positive and negative connotation is only used to describe how current alternates. In a three-phase circuit, you usually take one of the 3 current carrying lines and connect it to another of the 3 current carrying lines. One exception to doing this is described in the Delta versus Y video. As an example, let's use a three-phase 208 volt line. Each of the 3 lines will be carrying 120 volts. If you look at the chart, you can easily see the power output of any 2 lines. If one is at peak, the other line isn't at peak. That's why in a 3-phase circuit, it's incorrect to multiply 120 volts times 2 to get 240 volts. So if you're wondering why you have 110, 120 volts at home for your regular outlets, but you also have 220, 240 volt appliances, what gives? Well, that's not 3-phase power. It's actually 2 single-phase lines. So how do you calculate the power of combining 2 lines in a 3-phase circuit? The formula is volts times the square root of 3, which happens to be rounded off to 1.732. For 2 lines, each carrying 120 volts, the calculation for this is 120 volts times 1.732, and the result is rounded up to 208 volts. That's why we call it a 208 volt 3-phase circuit or a 208 volt 3-phase line. A 400 volt 3-phase circuit means that each of the 3 lines are carrying 230 volts. Last topic I'll talk about in this video is why do companies and data centers use 3-phase. Right now, let me give you a simple overview. For 3-phase, you connect line 1 to line 2 and get 208 volts. At the same time, you connect line 2 to line 3 and get 208 volts, and you connect line 3 to line 1 and get 208 volts. If the wire is capable of delivering 30 amps, then the power that's being delivered is 208 volts times 30 amps times 1.732 for total power available of 10.8 kilovolt amps. In comparison, for a single-phase 30-amp circuit carrying 208 volts, you will only get 6.2 kilovolt amps. Basically, three-phase delivers more power. There are other factors why it's far better to run three-phase power to a data center rack rather than using single-phase power, and those factors are discussed in the volts versus amps video and also in the 208 versus 400 volts video.